Hey, welcome to Ones and Zeros. My name's Ben, and today we are looking at episode 2 of our Unearthing C++ series. So today we're going to be following on from our last episode. So in the last episode, if you've seen it, we're talking about variables and having a bit of a look at the ways in which computers actually work and the fact that they basically have data and then using instructions in order to be able to manipulate and process that data. So today we're going to be taking a look at conditional execution or conditional branching. So basically allowing the computer to be able to do different things based on specific sets of information. So for example, we could look at a value and go, okay, if this value equals a particular thing, then we might do a particular set of instructions. Otherwise, we might go off and do something else. So a few different types of conditional execution and things like looping, which is quite similar, that we're going to be taking a look at today. So we're going to be starting off with if statements. Once we've had a look at kind of how those work, we're going to go through and have a look at while loops, which are kind of similar to if statements, but with the bit of a looping property with them. And then we'll also be having a look at things like for loops, which are a little bit more complicated, and then building up to switch statements as well from that point. So a few different things we're going to have a look at, and sort of building up to getting a bunch of skills that are going to help moving forward with looking at sort of more advanced topics and things like that. So we're going to jump over to Visual Studio, which we were having a look at last time, and that's going to allow us to take a bit of a look at some of the different structures that we were talking about just before. So first up, we're going to have a look at the most simple one of the bunch, which is the if statement. So in this case, it's a simple matter of, we might lay it out like this. And essentially, the structure of the if statement is we want to tell it that we're working with an if statement, and then we've got the brackets here with something inside the brackets, and essentially the if statement is going to take a look at what's inside these brackets, and if it's true, then it's going to do the stuff that's in here. Otherwise, it's going to skip it. So in this instance, we might create a uint8t, and let's just call it A, and we're going to pop a 0 in there. So going back to what we were discussing during the last episode, where we're looking at Boolean values and how we can take a number and get it to represent either a true or false. And we mentioned about typically the way a Boolean value is going to work is that a 0 is going to equal false, whereas anything that is not 0 is going to be equal to true. So I don't think I've had enough coffee quite yet this evening. So in this case, we've put a 0 into our A variable here, and we're looking at our if statement. So it's going if A, then we want to do what's in here. Otherwise, we're not going to do what's in there. And just to give a bit of an example, let's get it to send out some text for us, just so that we can sort of see how it's actually working. Like so. And we'll pop another one. Like so. So basically, if we run the stuff that's inside, we're going to get some text sent out that's telling us that it's from inside the if statement. And then we're also, just as sort of a control, so that we can see how it works, is after it's done whatever's the if statement's doing, we're also going to get it to send out some text just to show that it's now outside of the if statement. So at the moment, because we've put the value 0 into A, it's going to take a look at this and it's going to go, okay, that's false, so we're not going to do what's inside that statement. So if we run that, we can see that it's only given us the text that is outside the if statement. Now if we go back here and we change this to a 1, which is essentially any number that's not 0 is true, and we run that guy again, just hitting F5, then we're going to see that we're getting both the stuff that's inside the if statement as well as the stuff that's outside the if statement. So by manipulating whatever's in A, we can actually control whether or not it's actually going to execute the code inside the if statement. Now, we can also get it to sort of toggle between doing one of two different things. We can actually pop an else in there. And let's just copy this line here. And we're just going to go inside else. So similar to before, if A is true, whatever's inside the brackets is true, then it's going to run whatever's in here. But if it's not true, then it's going to do whatever is in our else statement. So at the moment, because this is still 1 or a true, then we're still going to get the same result as before. It's going to tell us that it's inside the if statement. So if we run that, just like that, and if we change this back to 0, so it's effectively a false, then it's going to skip over this bit here, and it's going to run whatever's in our else section of the statement there. So run that again. And we can see that it's given us inside else statement, like so. Now, the cool trick that we can also do here is start doing if statements that are essentially chained together. So let's pop in another variable there, call him B, and let's make him 1 for the moment. So we're going to go else if B. So this section here is effectively identical to what we've got here. Now, this is essentially two separate if statements, but they're going to work together in the sense that if A is true, it's going to run the code that's in here. However, if A is not true, then we're going to go down to our else, and it's going to then start this if statement and have a look at whether or not B is true or not. So in this case, A is a 0, which makes it false, so it's going to skip this. And let's change this up a bit. And we'll make it so that it's going to send out inside the second else second if statement. Fix that one up there like that. So if we run that one, we'll see that it's telling us that it's inside the second if statement because of the fact that A is false, which is our first thing that we're checking in the first part here, and B is true, which is a 1. And if we change B also to false, and we'll just close this one and run it again, it's actually going to skip over both of them because both A and B are false. It's actually going to run for me. Let's try that again. There we go. So as we can see, all we're getting this time around is that we're outside the if statement. And you can literally go through and say if we were to pop another variable in here and we were to make that one true, we can literally just add that in there and keep chaining them together as much as we like. You can have a whole pile of these, one after the other. However, for performance reasons, it's not typically recommended to have a bunch of them one after the other, and there is a way around that we're going to have a look at in terms of the switch statement a bit later on. However, what we're going to have a look at next is what's known as a while loop. So let's get rid of that one for the moment. And for this one, similar to the if statement, however, this time our keyword that we're putting in there is while. And then, same as before, we're putting a comparison in between the brackets. So it's going to have a look at whether or not what we've put in the brackets is true or false. And then, based on that, it's going to determine whether or not it's going to run what's in here. However, with a while statement, rather than just running it once, it's going to continue running that the entire time that what's in these brackets is true. So if we were to put in, let's just copy and paste from here. And let's put in inside while statement. And let's change this so that it's going to check to see if a is less than 5. Which it will be the first time around because we've set a to 0. And then what we're going to do inside each iteration of the loop is we're going to increase a by 1. Now we could just go a equals a plus 1. However, there is also a simpler way we can do that by just going a plus plus, which is basically going to do the same thing as a equals a plus 1. It's just going to add 1 to it. So what this should do is actually go through and loop 5 times. So we should get 5 copies of this text showing up. And then it's going to exit out of the while loop because at that point a is no longer going to be less than 5. And then it will run this bit down here for us. So if we run that now, we can see that, as I mentioned, it's done the inside while statement 5 times, and then we've got the outside text being printed in there. Now, there's also another way that we can approach the while loop, in the sense that we can do the comparison at the end rather than at the beginning. So, and in this instance, we should only get this happening 4 times, because the first time through, it's going to add 1 to it, and then second time through, it'll add 1 again, which means that with this comparison, the first time through, a is going to be 1 by the end of it, which means that when it does the comparison, we'll get 4 iterations of the loop before a becomes equal to or greater than 5. So if we run that guy like so, and might help if we actually fix our errors here. There we go. And doesn't look like I've actually done that correctly there. Now, why are we getting that 5 times? Let's have a look at that. So you can see the first time through, a is equal to 1. Continue that. A is equal to 2. A is equal to 3. A is equal to 4. And A is equal to 5. Okay, because the comparison actually happening at the end of it is the reason why we're still going to get 5 there. But essentially, the point is that with this one, rather than do the comparison at the start of each loop, it's effectively doing the comparison at the end of the loop. So similar sort of behavior. However, what we can do here is let's go A equals A plus 5, which means that it should only run the first time and then exit, which might give us a bit of a better example. Let's have a look at that one. So we should only get this inside while statement once, which we do. Excellent. Now, that gives us a simple way to be able to run through and loop things. And the while loops also give us the ability to go through and create infinite loops in certain situations as well. And there is reasons why this can be handy, which we'll have a look at. So in this example, we're basically putting while 1, and then anything that's inside this is going to run continuously. Now, with the microcontroller stuff that we're looking at in some of our other series, that can be incredibly useful. So in the sense where we pull up this particular bit of code, which is from our Discovering STM32 series that we're also doing on this channel, and we have a look in here, there's 2 main parts to the code overall. So we've got this first chunk here, which is us essentially getting everything prepared that we need for things to move forward. So getting basically all of the data and hardware and everything for the microcontroller all set up and running. And then as we can see here, we've got a while loop, which is basically going to go through and continuously loop in order to do the work that we need it to do inside there. So there is situations where that can come in handy. And we can also see in here some of the examples of where we are using if statements as well. Now, one of the most handy statements that we can take a look at excuse me, is another type of loop that does conditional execution as well, much like the while loop, but gives us a bit more flexibility on how we go about doing that. So let's get rid of these guys for the moment. And then similar to doing if and while, this time we're going to go with for. And again, we're going to go with some brackets. And let's just pop a couple of bits in here, and then I'll explain what they're actually going to do for us. Just copy and paste this guy as well. And we'll change this one. So essentially what's going to happen here is we're going to get the same 5 times that this goes through. We'll see inside for statement come up 5 times, and that's controlled by this stuff in here. And there's actually 3 parts to inside these brackets. There's the first part, which is something that gets set up prior to the first loop occurring. So we're basically telling it that we want to create a variable that's a uint8t, or a single byte. We're calling that one I, and we're putting a 0 in there. So it's going to create that for us, and then it's going to do a comparison against that the first time through. So it's going to check if I is less than 5, which in this case it will be because we've put a 0 in there. And then it's going to go through and run this. And once it's done that, it'll come back around and it's going to have another look at that comparison. But the other part that it's going to do prior to that is it's going to have a look at this here. So we're essentially telling it that we want to add 1 to I at the end of this loop. So just to go through that again, it's going to create a variable called I, make that equal to 0 prior to actually starting the loop. It's going to have a look at this comparison. So in this case, I is equal to 0, which is less than 5. So it's going to go through here and execute this line of code here. Then it's going to add 1 to I. And then once it's done that, it's going to come back around and look at that comparison again. So for each of those loops, it'll do this bit at the end of the loop and do this bit at the start of the loop, while this first part gets done prior to any of the rest of that occurring, which is going to allow us to basically tell it we want it to do what's inside this loop 5 times. And we could change this, we could make it 3, or we could change this to 5, and we could make it so that it checks if I is greater than 0 and then subtract 1 from each of those. And if we see how that works, like so. So we're still going to get 5 loops. And that allows us a bit more flexibility in actually creating a loop like we would with a while statement, but giving us a little bit more control over what's happening. So you could do the same thing as this using a while loop, but this allows us to have a bit more control over the value that it's using for the comparison, as well as the comparison itself, which this part is similar to what we're doing in a while loop. And then we're also being able to modify what's going on with I as well. Now, we can simplify this a bit so that you can sort of see its similarity compared to a while loop. So let's go back to creating an I that equals 0. However, we're going to do that outside at the start before we even get to the for loop. And we're going to do it similar to what we did with the while loop. We're going to go I is less than 5. And let's delete that bit for the moment. And we're going to pop that in here. So this is essentially going to do the same thing without utilizing the extra parts of the for loop. So rather than having this inside here and this inside here, we can do it this way, which would allow us to do it similar to a while loop, like so. So still going to get exactly the same behavior, but we've also added a couple of extra lines of code, and by doing it with these bits inside the for statement, it allows us to see a little bit neater about what's happening with that loop there. So just taking up the one line and having all of the information involved in that for loop being in that single line. So it can be quite a lot more useful with doing that. Typically, if I'm going to get something to loop in a bit of code, I'm probably more likely to use a for loop simply because it gives that extra little bit of control. And moving forward, we will start to have a bit of a look at some of the examples in future episodes of where that's going to start to become really useful for us. Now, the other thing that I wanted to take a bit of a look at is a switch statement. So, as I mentioned before, we can go through and nest a bunch of if statements. I'll let it format it that way for the moment because it's still going to explain what I'm looking for. So we could have if A else if B, else if C, and we could have a whole bunch of these, allowing us to determine what's actually going to get executed in here. And we could also say if we change it up a bit like this, so we'll just use the one variable for the moment. Go with A there. So in this instance, what it'll go through and do is tidy it up a bit so it looks the way it did previously. There we go. So we're just using the one variable, popping a value into it, and then it's going to go through and go compare A to 0. If A is equal to 0, then it'll do what's in here. If it's not, then it's going to go and check on this one to see if A is equal to 1, and then it'll do what's in here. If it's not equal to 1, it'll continue on, and then it's going to check if A is equal to 2, and if it is, then it'll do what's in here. And if not, then it's just going to continue on. So just so that we can sort of see how that works, much like our first example, let's just pop some text in here. Go A is equal to 0. We might just copy and paste that. A is equal to 1 and A is equal to 2, like so. So if we run this at the moment, because we've put a 0 in there, we're going to get A is equal to 0. So just so you can see that, like so. So it's telling us A is equal to 0, so it's running the code that is in this line here. Close that. If we change this to say 2, then it's going to skip over this one because it's not equal to 0. It's going to check if it's equal to 1, which it's not, so it'll skip over that, and then it's going to check if A is equal to 2, which it is. So it's going to tell us that A is equal to 2, like so. There we go. Now, we can also go through and say if we put 5 in there, it's going to have a look at all three of these comparisons that we've put in here. None of those are checking if A is equal to 5, which means that it's going to skip over all of these, and we're just going to get the text put out that says we're outside. Let's change that to if, to let us know that we're outside the if statement. So if we run that and see that that's the only text that we're getting sent out there. Now, doing it this way can take a bit more of a performance hit than using a switch statement that we're going to have a look at, because it's running through and doing each comparison one after another. So the way a switch statement works is, if I can type properly, we're going to do it like so. Again, I'll explain this in a moment. Go let's pop a couple more of these in. Indent those a little bit so it looks a little bit easier to understand, and we'll fix up the numbers for these guys. So this is basically going to do exactly what we're seeing with the if statements before. So we're telling it that we want to go with a switch statement, and that the thing that we're going to be working with is A. So much like we did with the if statement. However, this time we've got these 3 blocks here, which are our case blocks. So it's essentially going to go in the case that A is equal to 0, it's going to run what's in here. If the case is equal to 1, then we're going to do what's in here. And if the case is equal to 2, then we're going to do what's in here. So if we change this back to 0, we're going to see we get a similar behavior to what we got with the if statements. And like so. and forgot to pop in the bit to put the end of the line in there. So let's pop that in there and we'll run that again just so that that looks the way it did with the other one. There we go. So we can see that A is equal to 0. Now, one of the differences with using a switch statement is you can see that we've got these break statements in here as well. So what these are basically doing is if the case is 0, it'll go through and do this, and then we're telling it to break out of the switch statement and continue on with the next line, which would be line 20 here. The reason we need to do that is because the way the switch statement works is if it comes into, say, case 0 here and runs this line of code, by default, it's going to continue on with the next case here and go on from there. So for example, so that makes a little bit better sense, let's get rid of these break statements. And what's actually going to happen here is it's going to go through, it's going to compare A to 0, which it is, as we've put that up here. It'll run this, and then it's going to continue on through this switch statement one after the other, which means that we're going to see A equals 0, A equals 1, and A equals 2. So if we run that, it's going to do all three of those guys. So in order to prevent that from happening, we go through and we pop a break statement in there so that it knows that at the end of that bit that we have to break out of the switch statement there. Like so, which gives us the same behavior we were seeing before. Now the benefit of that is that we can actually set this up so that if it equals 0 in this case, we could actually have it so that it runs a particular set of code in here. But say if A is equal to 0, we also want it to do what's in here, then that's what it's going to do here without that break in there. It'll do this one and then this one in the case where A equals 0. But if A equals 1, then we're just going to get this here happening rather than it doing both. So if we run this at the moment, we're going to see A equals 0 and A equals 1. Losing my voice already, like so. However, if we change that to a 1, we can see it's just going to do the A equals 1 and then exit out of the switch statement because of this break here. Now you can also use break in while loops and if statements and things like that as well to break out of those if you get to a point where you don't want it to continue on with that, which is something that can be quite useful in certain situations. One of the other things I really like about switch statements, aside from their performance benefit over having a bunch of chained if statements, is we can also pop in here default. So let's pop this in here, and the text we'll use there, we'll just go with default. So what this is going to do is it's going to have a look at A, and if we put a 5 in here, for example, so make A 5, then it's not going to be equal to 0, it's not going to be equal to 1, it's not going to be equal to 2, which means it's not going to do any of these three. So what default does is this will get run in any situation where it's not equal to any of the things that we've put into the case statements there. So for example, because A is equal to 5, and it means it's not equal to 0, 1, or 2, then it's going to run what's actually in our default there. So if we run that, then we can see we get our default. So that's a bit of an overview of how we go about doing conditional execution and using conditional statements. So our if statement, our while loops, our do while loops, for loops, and our switch statements, which are the main tools that we're typically going to be using when we want to be able to control the flow of instructions to get the computer to do different things based on a particular value or a particular state within the program. So I'm going to have a look moving forward in future episodes at some of the ways in which we can utilize that to be able to control how a thing executes. But if we jump over to this code here, we can sort of have a bit of a look at this anyway. So perfect example right here is essentially what this code is going to go through and do is with this if statement, it's going to go through and run this system initialize function, and functions are something we're going to have a look at in the next episode, so I'm not going to go into much to that now. But essentially what will happen is system initialize is going to give us a value that is false if it has succeeded, and it's going to give us a value that is equal to true if it has failed. So in this case, if it gives us a value of true to indicate that it's failed, then it's going to come in and run this bit here, which is a while loop, and we can see from the while one that it's what we're talking about before, where we actually have an infinite loop. It's just going to get stuck in that while loop and keep going over and over. The reason why we'd use something like that here is if it's failed to actually initialize the start of our program, then the benefit of this is we don't want it to actually continue on with the rest of the program, because something's got to be kind of broken in order for it to fail in the first place. So we chuck it into our infinite loop. If it has succeeded and we get a false back out of this, then it's going to go, okay, well that's equal to false, so I'm not going to do what's in here, so I can continue on with what we're doing for the rest of the program. If you're interested in having a look at some of how that is used, then you can check out our Discovering STM32 series, which we do go through and have a look at not just while loops and if statements, but there is also switch statements and for loops in there as well. But in order to avoid making it too confusing so far, that's pretty much where we're going to leave it for the moment. So just to have an understanding that we have those particular tools that we can use to be able to control what the computer's doing based on a particular state or set of information or set of values. As I mentioned, we're going to have a look at functions in the next episode and have a look at what they are and how we can use them. So similar to the function that we saw in here, the system initialize, so that we can see how we can create one particular block of code and we can reuse that in different situations to be able to avoid having to rewrite the same bit of code over and over again in different locations. We can create that one function and utilize that multiple different times. So thank you for watching. If you like that, please follow us on Twitch if you're watching on Twitch. If you are watching on YouTube, I'd love it if you like the video and hit subscribe. We do also have a subreddit r/ones and zeros, which will come up at the end of the video. So you can jump on there. If you've got any questions or would like me to go a bit more in depth with any of what we've talked about during this episode, feel free to leave a comment on the video or on Reddit. There is also an email address that'll come up in a moment, so feel free to send me an email if you prefer to do it that way. I'm happy to try and answer any questions and help try and make things a bit clearer if they're not already. So again, thank you for watching.